welcome faculty from Asia. It's especially great to see some of my friends, collaborators, Professor Renxiang Shi from Japan, Professor Jae-Real from Korea, and especially my former student, Professor Suman Choi, who's now a very successful faculty member yourself. I guess that's the biggest reward for us educators, is to produce successful people. So I've been at Purdue for 14 years and decided recently to join Microsoft to change the world, so to speak, in the only way I know how, which is to put haptics technology into the hands of millions of people. But today my talk will focus on the group I'm managing, the Human-Computer Interaction Group at Microsoft Research Asia. So these are my guys. Cao Xiang, you are actually here somewhere. Over there. Darren Edge, Sergio Palatino, Jiawei Gu, and Koji Yatani. I think we all agree that computing devices are becoming more capable of sensing and acting. Now computers know where I am, where I'm looking at, can hear my voice, understand what I'm saying, and now can even feel how I touch the computer screen through my finger gestures. Instead of focusing on smaller, faster, and cheaper, which a lot of people are doing, they're all very worthwhile endeavors, human-computer interaction is about making technology more accessible and finding interesting uses for them. So the ultimate goal is to interact naturally and gracefully with voice, gesture, touch, etc. At the Microsoft Research Asia, the Human-Computer Interaction Group is a very diverse group. We have computer scientists, we have technologists like me, who's now focusing on haptic technology, and we have designers, industrial and interaction designers. We like to think that we create the sensors, devices, interactions, and the scenarios that will drive the next generation of natural user interfaces and reshape human activities for the better. So I'd like to give you some examples, sort of a glimpse into the future of HCI by showcasing some of the excellent work we're doing. So the first project is called a PICOntrol. It's using a handheld projector for direct control of physical devices through visible light, and it's led by Cao Xiang. The idea is that instead of having this visual display of controls and you move your mouse to click here and there, what if you take a projector and move that projected image onto the things that you're trying to control?
We are introducing PICOntrol, which enables the user to freely control various physical devices using a handheld projector and inexpensive sensor units. To control a device, the user aims the handheld projector at it, casts the projected interface component over the sensor unit, and issues a command by pressing a push button. Controlling another device is as easy as pointing at it. We use an off-the-shelf handheld projector. 3 push buttons are added to enable basic input on the projector. The first button activates input on the target device, while the other 2 buttons allow switching between projected interfaces. The sensor unit comprises a photosensor, an indication LED, and an optical diffuser. In our prototype setup, it is connected to an Arduino microcontroller, while in the future it may be integrated into various electronic devices. The image contains both the visible interface for the user and the embedded control information for the sensor unit. By changing pixel brightness at a high frequency, different areas can transmit different temporal codes within the same interface. These codes can either send a control command, allowing the user to activate various functions in the interface.
So you get the idea. What you do is you take a handheld projector, you point, you project, and then you control that object. We use the off-the-shelf handheld projectors and low-cost photosensors, and then the control signals are actually embedded in the projection. So when you press that button down and point the projector onto an object, the control area is actually sending binary code. So wherever the photosensor happens to land in that area, picks up that code. And we use the peer-to-peer communication, so we don't really rely on Wi-Fi or any other connectivity around us. So this is sort of an example of a creative use of technology. And I'd like to move on and give you the sort of different project called the MicroMandarin that's led by Darren Edge. Here the idea is that despite the best of intentions, we have a lot of foreigners in Microsoft Research Asia. You think you're going to come to China, you're definitely going to learn their language because they can be immersed in the environment and all that, but you get busy, right? And who has the time to take language lessons every day and all that? But if you're busy, we can do what's called a micro-learning. We can let you, whenever you catch a break, you can do your learning on your cell phone. And what's more, we know that you're going to the bank, and we're going to give you flashcards that actually contain only the vocabulary that's relevant for your next task, because then it'll encourage you to actually speak when you go to the bank, and then have the vocabulary that you need. So let's take a look. 这很响，稍微轻一点好吗？ So now he's heading to the subway station, and the appropriate words about train fare and all these things come up. So the way it works is that we use 4 squares to sense where the user is located, and then a pop screen comes up and say, can you confirm you're there, you're in that area, and then just pick the nearby venues. So, I'm going to a bank, I'm going to a cafe, and once you pick that, an appropriate subset of flashcards will come up, and then you notice the user is looking at it and flipping around. And also there's a green and red button that lets the user say, yes, I used that phrase today. No, I haven't used it today. So it tracks how much the person uses that language. So a user study was conducted, lasted 4 weeks long. There were 23 people located in Beijing and Shanghai. And these people basically were given 2 ways of learning. One is the micro-learning or context-based learning is what we call it. And the other one is the more traditional frequency-based learning. So this is having flashcards based on how often these words are being used. And then everybody used both methods, and we did a comparison. So what we found was that in terms of, on the left side, context-based learning, micro-learning really fits a very busy lifestyle. Studying context-relevant words really encourages their use on the spot. On the other hand, this is not like context learning is better than the traditional frequency-based learning, but rather it really depends. For example, for a beginner who really needs to master a basic set of vocabulary, they still prefer frequency-based drilling to get a bit of basic stuff down. And also, some people just really want to improve their language skills, not particularly use it in the next 5 or 10 minutes, and they still like the frequency-based one. So you notice that this is a piece of work that's based on theory, and also contains a bit of sort of design in terms of how you would do the software of the interaction. So let me move on to an even more design-based project called the Reaction Media, led by Sergio Paulotonio. Here the idea is that our first reaction to something is the most precious, right? You watch a video and you watch a movie and all that. You have your first reaction to something, and it's precious. And when people are not co-located, and when you want to communicate that first reaction to someone you love, your friends, and all that, what would you do? How would you do that? So here's the idea.
We love spending time with friends, but we are not always together. Thankfully, today we are all well connected. We share texts, music, photos, and videos. Among all these media, it's video that captures the most. Videos carry our memories, stories, and emotions. With online video sharing today, our reactions and stories are left behind, while in real life, facial expressions are the key to communication. So, what if we tell the whole story? Let's begin with reaction media. This is Jack. He goes to the computer to check his email. He receives an email from Mary about reaction media. When he opens it, he sees that Mary is inviting him to check out a video. In the corner, Jeff sees Mary's photo. He enters reactionmedia.com, where, after logging in, he can watch the video that Mary sent. Mary's reactions are played inside the video clip, and Jeff laughs at her familiar but unusual facial expressions. Meanwhile, his own reaction is being filmed. He can click to view it, along with his friends' reactions. When he clicks further, he can see more people, and is able to choose anyone's reaction to play inside the main window. If Jeff finds his own reaction or other people's reactions interesting, he can attach it to the video and share it with his friends. His friends will receive an invitation email, just like the one he got from Mary. Eventually, Jeff gets to know his friends in a whole new way. For example, he learns that Mary loves babies so much, and Tom always eats, no matter what kind of video he's watching. Jeff becomes more and more open to show himself, and starts to visit reactionmedia.com every day, always curious to see his friends' reactions. By inviting and sharing, Jeff finds himself getting closer and closer to his friends. Reaction media works for Jeff because it's richer. Not only does it enhance the videos he watched, it also gives him a chance to truly know people. All he needs to do is just watch and click.
So here's an example of how we actually do interaction design to enhance emotional connections between people, and that leverage the fact that everybody uses online media these days. So you start with a vision of what you want to achieve. In this case, it's emotional connection. You create concepts, and then you prototype. In this particular one, it's a video prototype, and then you go on to do the software prototyping, and then you put it out in the real world. This is one aspect of the design we do, and another aspect is more focused on industrial design. Jiawei Gu is a young researcher we have in our group whose background is industrial design. So in Jiawei's work, he would start with a scenario and the user interface. In this particular example, we're looking at Link wireless headsets. So Link is this wonderful program that we use within Microsoft to communicate with colleagues, not just in Beijing, but everywhere around the world. This is a depiction of some of the pain points that you might say that when you use Link to communicate. Here's on the upper right, here's somebody whose microphone is not properly plugged in, so as she's talking, the voice is leaking, and the people behind him, the co-workers, just want to kill him. There's, in the bottom middle is that, you get connected, the first thing you say is, "Can you hear me? Can you hear me?" Isn't there a better way to start a conversation? So you design, you sort of do the analysis of your users and look at all these things, and then you do what's called a scenario-based sketch. So here, every panel Jiawei has is meant to solve a different problem. For example, what do you do if you, on the phone so much, you forget to charge up your battery? On the upper left, what would be the form factors that are really make a Link wireless headset really ultra mobile? Here's another sketch Jiawei has done. Actually, it's a laptop cover for students that fit their lifestyle. For example, you can see on the upper right, there's a handle. So when you have a backpack and everything, you can pick up your laptop easily. In the middle, you can see the clock and the email show up. So you don't have to really open up the cover in order to get a quick glimpse of sort of what new email is coming and all that. Again, these are a lot of concept drawings, and then you work out the mechanical details, and then you do the physical mock-up, and hopefully it will lead to some products someday. So we're getting into more hardware-related designs now, which is a good time for me to describe BodyScope, led by Koji Yatani. I think the video speaks for itself, so let's watch.
We developed a wearable acoustic sensor called BodyScope. The chest piece of a stethoscope is attached over the microphone embedded in a modified Bluetooth headset. It is designed to be positioned on the side of the user's neck in order to amplify the sound inside the body and eliminate external noises. The BodyScope sensor is intended to be worn around the neck. This device supports the classification of sounds recorded near the throat rather than what we might normally hear.
So here's Koji eating and drinking as part of his research.
The two sound quite different. The two sound quite different.
We will now show you some of the sounds recorded by the BodyScope. The sound recorded by the BodyScope is shown in the spectrogram. When the user is sitting, we can see weak signals below 70 Hz. This cycle consists of 2 parts, so we believe that it is the heart sound. When the user is taking a deep breath, the BodyScope can sense the sound of inhaling and exhaling.
To get an idea, you'll get different signals when you laugh, when you speak, when you whistle, when you sing, and all those things. So BodyScope is a wearable sensor that records the sound in the user's throat area, and it can recognize different activities. Right now it's got a recognition accuracy about 80% in the lab and a bit lower in the wild. So the last one I want to show you is my own project, Haptics. This one is about providing sliding and clipping feedback on otherwise smooth piece of glass to facilitate typing in this particular case. 这个也很响，调低一点好吗？ Okay. In this demonstration, we show a new haptic display that delivers touch feedback to a finger on the touch screen. We provide different feedback depending on whether the finger is sliding on the screen or clicking an object on the screen. 2 scenarios have been developed. In the first scenario, we show a button clicking demonstration. The second demo shows a thumb typing scenario. The first scenario is incorporates sliding and clicking haptic feedback into a thumb typing scenario. The left thumb moves up and down along an arc in the lower left corner of the touch screen. This is mapped to 3 letters in a vertical alphabet display. The user selects desired letter with the right thumb. 3 buttons can be found at the lower right corner of the screen. Clicking on the top button selects the top letter. Clicking on the middle button selects the middle one, and so forth. This way, the left thumb does the positioning while the right thumb does the selection. The locations of the arc for the left thumb and the 3 buttons for the right thumb can be felt as a different texture by sliding the thumbs on the touch screen. A key click feedback is triggered whenever the right thumb taps on one of the 3 buttons. The haptic display shown in this demo provides... So the nature of haptic work is that unless you feel it and touch it, you don't really know what I mean. So I brought the hardware, and tomorrow I'll be the demo fest, and I welcome all of you to come and give it a try. So I hope that giving you a bit of flavor of the kind of work we do, we're very interdisciplinary. Each project may seem very different, but they're all designed very specifically to explore a particular sub-area at the intersection of many different sort of disciplines. And we believe that this is very important because it's in those areas that we're very likely to bring true innovation to human-computer interaction. Thank you very much.